So, thank you for joining me for this third video on quadratic equations. So, we've solved it using factorisation, we've solved it using the equation, and we've used the equation and also geometry to identify how many roots there are. For now, I'm going to tell you the final way of solving a quadratic equation. It's called completing the squares. And this way is also the method, completing the squares. I'm not very good at multitasking, as you can see. But this method is also useful for deriving the equation that we saw before. Just as a recap, let's write that equation down. X equals minus b plus or minus square root of b squared minus 4ac. So, I'm going to show you how we get that. So, given the equation, ax squared plus bx plus c equals 0, if we want to find the root to this, what I'm going to do is say that this is equivalent to, well, I can say it's equivalent to anything really. This is equivalent to a equals 0, where a equals ax squared plus bx plus c. I'm sure you agree with that. I've just defined a to be what I want. In fact, it's the same as a plus 1. It's equivalent, where a equals ax squared plus bx plus c minus 1. The minus 1 and plus 1 will cancel out. I can say it's equivalent to anything. And in fact, what I'm going to do right now is say that it is equivalent to a x plus b over 2a squared plus a, there's that big A, equals 0. And I'm going to try and find out what that a is equal to make the two equivalent. So, how do I do that? Well, I'm going to open out this. When we open it out, we end up getting a x squared plus b x over 2a plus bx over 2a. Let's bring it back. Plus b squared over 4a squared. I'm just opening out that squared, that square number. And then plus a equals 0. I just opened that equation out. So the bottom equation is equivalent to this equation. Now I'm just going to multiply the a that's outside the bracket. I'm going to bring it in the brackets, and that's going to give me ax squared plus, before I multiply the a's by this, I'm going to bring these two together to get bx over a, and then when I times by a, I just get bx. I hope you can see that. Plus, what else is there? The b squared over 4a squared. When you times by a, one of the bottom a's is going to cancel out, and we'll be left with b squared over 4a. And then I'm left with this big A again, that hasn't changed, and that's it. So, let's compare it to the top equation. Are they equivalent yet? Let's do it in red pen so you can see, you know which one's which. Plus c equals 0. Well, it's almost equivalent. That looks very much like that. That looks very much like that. That looks very much like that. Uh-oh. That does not look like that. But we can define A to make it look like that. We can define this big A to make it look like that is what I mean, not the small a. The big A. The small a is fixed, remember? It's given in the question, A, B and C. But the big A, we defined. So let's try and define it so then it's equivalent. We need to define A such that B squared, let's do it in black, don't want to confuse anyone, including myself. Okay, mostly myself. Okay, all myself. I get confused easily. And can't multitask, as you saw earlier. But what I do know is that B squared over 4A plus big A equals C. Or that's what I want, rather. Now let's rearrange that. We will get, let's bring the B squared over 4A to the other side. You get A equals C minus B squared over 4A, little a. And that's what we have. Brilliant. So now I'm going to write this equation again. And yeah, see if it is truly equivalent to this. It will be, but let's just show you. So we have left with ax squared plus bx plus b squared over 4a plus big A, which equals to c minus b squared over 4a equals 0. And obviously this b squared over 4a cancels out with this minus b squared over 4a, and we've got ax squared plus bx plus c equals 0, which is what we have. So all we need to do in life is let this big A equal to c minus b squared over 4a in the original equation. So let's do it. Let's rewrite this again, but with that big A substituted in for what we now want to define A as. So, in fact, I'm going to do it here. So what we have learnt is the top equation is equivalent to c, let's just add c minus b squared over 4a. C minus b squared over 4a, little a, equals 0. The two are very similar. And you can do this at home. You can expand the bottom equation out to get the top. But we've kind of derived it. And if you've been following, you'll know that the two are equivalent. So if we solve the top equation, we solve the bottom equation. The two solutions are exactly the same because they're equivalent. They just look different. So let's try and solve the bottom equation. What I'm going to do is write it all out again. Let's write it all out on this page because I don't want to keep scrolling. I spend a lot of time scrolling, not enough time writing. So let's do it here. So first of all, let's bring the c minus b squared over 4a to the other side. So we'll be left with ax plus b over 2a squared equals, bringing it to the other side, is b squared over 4a minus c. And in fact, I'm going to times it by 4a and then divide it by 4a. Doesn't actually change anything. Times something by the same number and divide it by the same number, it don't change anything. The reason why I'm doing that is so then I can merge the denominators together. As you know, you can only merge the denominators together if you can only merge two fractions together, so minus or plus, if the denominators are the same. So I've just done that. Okay, now let's divide this this a out of the left hand side and bring it to the right hand side. So divide both sides by a. That is lost, and on the right hand side we end up with a squared on the denominator. Then what we're going to do is square root both sides. That cancels out. And we are left with x plus b over 2a equals square root b squared minus 4ac, or ca, but it's the same thing, over square root of 4a squared, which is 2a. It's looking very similar to the equation. One more thing we need to do. X equals, let's bring the b over 2a to the right hand side by minusing it. We get minus b over 2a plus b squared minus 4ac over 2a. And also minus, because when we have a square root we can either take the plus or minus side. So we're done. That looks very similar. Some might say exactly the same as the equation that we had, and that's because it is. So this is a method of completing squares. I might do a video showing you an example of how to use a completing squares to solve a real life numerical quadratic equation example. I'll try and do that in the next video, or if not, then another video. But for now, I hope you've enjoyed this. I hope this has been educational and you've learned how to do quadratic equations. I hope now you'll be willing and able to solve any equation that your teacher or examiner throws at you. Thank you very much for listening. It's been a pleasure as always, and I'll see you for the next video.